Okay, so now for the second part of week 3 lab. This is dealing with pH, and I'm going to share that with you and we'll go through this lab. Okay, so pH. So pH is, the pH scale is a measure of acidity or alkalinity of a solution. Before we get too far into that, we really need to recall the definition of an acid or definition of a base. So an acid is something that is going to, a substance that's going to release hydrogen ions into solution. So the hydrogen ion concentration is going to increase. If we are talking about a base is going to release hydroxide ions into solution. So hydroxide ion concentration is going to increase. So strong acids and bases will completely dissociate into their component ions. So that, for example, hydrochloric acid, HCl, will completely dissociate into hydrogen ions and chloride ions. Sodium hydroxide, a strong base, would dissociate into sodium ions and hydroxide ions. If they are weak acids and bases, and they don't completely dissociate. And the example he uses in here is carbonic acid, which is right there, H2CO3. That dissociates into carbonate ions and hydrogen ions. And that is actually very important when we're talking about buffering blood pH. I'm sure you'll talk about that in lecture, but we don't need to get into too much of that right now. So the pH, which ranges from 0 to 14, anything with a pH of 7 is considered neutral. Pure water has a pH of 7. Anything below 7 is acidic. So the lower the number, the more acid it is. Anything with a pH above 7 is considered alkaline. So the higher the numbers, the more alkaline it is. And mathematically, if we want to relate hydrogen ion concentration to pH, the pH is equal to the negative log of the hydrogen ion concentration. So for example, if the hydrogen ion concentration of a solution is 0.1 moles per liter, we express that as 1 times 10 to the negative 1 moles per liter. The negative log of 10 to the negative 1 is 1. So the pH of the solution would be 1. Okay? If the hydrogen ion concentration is 1 times 10 to the minus 3, the negative of that would be 3. So it would have a pH of 3, and so on. So you'll notice that an increase or decrease of 1 pH unit represents a 10-fold increase or decrease in the hydrogen ion concentration. Okay? Let's see. Serial dilutions. Serial dilutions, I don't usually do these in the lab because this is just asking for trouble, but we can do a serial dilution here. And the way you do that is you make up your initial stock solution of whatever concentration it is, and then you do a 10-fold dilution in each step. So you would take 1 ml of your stock solution, add 9 mLs of water. Now you've diluted it 10-fold. Then you would take, from solution number 2, you would take 1 ml, add it to 9 mLs of water. Now you've diluted it another 10-fold. So it's a 10-fold dilution each time. The problem with that is if you make a mistake in your measurements of volume at any point along the way, everything from that point forward is going to be wrong. So when you're making serial dilutions in the lab, you have to be really conscious of what you're doing. The other thing is if we're talking about pH with a serial dilution, what's going to happen to our pH every time we dilute 10-fold? The pH would change 1 pH unit with each dilution, right? So each time we dilute it 10-fold, we're going to change the pH by 1 pH unit. So if you start out with a stock solution of 3, you're going to dilute that down. So the pH would actually go right? So it's going to become less acidic as you dilute it down. Same way if we start out with a stock solution with a pH of 10, I dilute it tenfold, now the pH is going to be 9, then 8 and 7 with each tenfold dilution. So it's a little tricky. You have to remember the relationship between hydrogen ion concentration and pH. Then it goes through the whole lab procedure, which unfortunately we cannot do, but we can fill in our table here. And I'm just going to give you these pHs so that you can answer the questions that come up afterwards. So you're going to have a stock solution initially in tube 1 of an acid, HCl, with a concentration of 0.1 molar, and that pH is 1. That's a very strong acid. So we're going to dilute that tenfold, so you get 1 change of pH unit. So test tube 2 would have a pH of 2. Likewise, test tube 3 would have a pH of 3. Test tube 4 would have a pH of 4. Then in our other set of test tubes, we're going to start out with a stock solution of a concentrated base, which is 0.1 molar sodium hydroxide. And that has a starting pH of 13. It's a very alkaline solution. So now we're going to dilute that tenfold. So now our pH would be 12 in tube 6. Dilute that tenfold, we go to 11. Tube 8, another tenfold, we'd go to 10. And the pH of our distilled water, which would be pure water, would be 7. Okay? So now you can answer the questions based on that table of data. The last question, if any of your results were not as you expected, what could some explanations be that might have happened? Again, if you didn't dilute properly anywhere along the way, then your pH would be different than expected. Also, if you let your distilled water, theoretically, if you let your distilled water sit out in the air, some carbon dioxide could have dissolved in the distilled water, which is going to release, carbon dioxide, when it dissolves in water, makes carbonic acid, which would release hydrogen ions, although that change would probably be nearly undetectable. The biggest problem, again, with serial dilutions is just watching your volumes when you are diluting. That's the biggest issue. There are also exercises for pH on Pearson. If you want to go through and just have some extra time with pH, you can certainly do that. Again, I'm going to send, there you go. I'm going to send along this video along with the other video and the little review sheet that I have for you. And that should help you do these 2 exercises for lab week 3. Okay. I'm also working on a study guide for you guys that I will send out later with plenty of time before the lab practical so that you can focus your studies a little bit, help you get through that one. Okay. All right. So again, if anybody has any questions about any of this, just email me. If you have not yet sent your week 2 labs in to me, please do that so I can get them all in, get them all corrected and send them back. And I will see you Tuesday or Wednesday or Thursday. Okay? Have a good night.